Thanks everybody to be here. It's the last slot of the day. You are pretty tired. It's good. It won't be a very deep talk. It's introduction level, so everything will be fine. If at any point you have questions, you are welcome. You don't need to. You shouldn't wait until the end. Feel free to ask them if it's okay.
Sure.
It's okay? Okay, perfect. So yeah, I'm Nicolas Frankel. As you can see, I'm quite old. I was a developer for a long time, developer, architect, whatever. And I was a consultant, so I went to different customers. And basically, I always encountered the same problems. They were not technical problems, they were organizational problems. And I had to solve them with technical solutions, which was not super fun. So I decided, hey, let's leave this world, and now I'm a developer advocate. The good thing is, I'm here, I'm talking to you, we can talk, we can communicate, I give you advice, but afterwards, you do whatever you want. I'm not a consultant anymore. So as I mentioned, I'm quite old, probably, and I started doing web stuff in 2000. Who here started at the same time about, yeah, that's what, more than I thought. Well, you cannot be, you are like 20, 25 top. Yeah, and it was really like the pioneering age at the time. So just something that I want to emphasize, please be careful with the words. There is something called the internet, and among that there is something called the World Wide Web. Those are not the same. I see them changed like all the time, used for one another. They are not the same. Like internet is much bigger. World Wide Web is just like communicating with HTML documents. Like Hari destroyed half of my speech today because half of what I want to show you was in his slides. So anyway, when I started, and to be honest, I started on my own because at the time since there was no World Wide Web, or it was the beginning, learning HTML, as you can imagine, was not super fun. You had to look at the source code. But to look at the source code, you had to understand what it was. That you had an HTML document that was rendered. I used something called Hotdog Pro at the time. Do you know Hotdog Pro? It was the height of technology. Basically, it had all the HTML tags of that time, and you would click on them, and they would put it in the HTML documents. And of course, you had to click the ending tag as well. Imagine, that was the summit of the technology. And we had images. I started with images. I don't know who started without images here. The old guy. Yeah, yeah. That was fun. But I had no CSS. I was lucky I had no JavaScript either. And so to do the buttons, to have nice, with this bevel, sorry, we used a table with different colors. It was really ugly, right? Yeah, I know. I did it. And then once I started doing HTML and stuff, I was interested in, okay, but how does it work? Okay, you have this HTML, you put it somewhere, then you get different results for a browser. And I discovered web servers. And what was amazing is that at the time, it was pretty straightforward. A web server was meant to serve static content. The stuff that now we say, it's just caching, just put it somewhere. That was really amazing. But somebody decided that it was not enough. So to be honest, I don't remember which web server I used. Well, not I used, but I was provided with at the time. Now I remember it might have been Apache web server. I hope so, I think so. And yeah, we had CGI scripts. So basically, as Hari mentioned, you had a dedicated executable. So every request would generate like a thread and then it would consume memory. And also, the fun part is you would create a program that would generate HTML. So I don't know, I come from the Java world. For me, that is like creating a servlet to generate HTML is like crazy, and that's why they invented JSPs. That's exactly what happened like 15 years before or 10 years before, is that somebody decided it's really, really a bad idea, like from a performance point of view, but also from a design point of view. What I want is I want to have a web page and I want to insert like dynamic snippets, like the dates, the author, whatever. And then came PHP. And PHP stands for? Yeah, you know the trick, huh? So are there any PHP developers here in the room? Sorry for you. Are there other PHP developers in the room? Yeah, I understand. Yeah, the PHP developers are very proud to say, yeah, it's like a hypertext preprocessor. No, it means personal homepage. And after a while, they realize that doesn't make super professional. If we want to market it, then we need to rename it. But yeah, bad stuff happened. And so this became super successful. We were not only doing personal home pages anymore, but like industry actors starting to decide that, hey, it might be a channel that we need to invest in. And yeah, they started to do communication. And that meant that when you start to do communication on a channel, you want that channel to be reliable. And so it was not a simple web server anymore. You had probably to provide different web servers with load balancing in front. And so the web server, which was, again, initially just like designed to serve static content, had to do something more. Like perhaps there was one web server in front to do load balancing and then other web servers to serve static contents. So the web server had to evolve. And then afterwards, when the World Wide Web became really ubiquitous, now this web server did also had to route, because before we had like redundancy, so where they were all having the same content, but now we want, when a request comes in, that to like direct, to forward this request to another server, or perhaps another server, or perhaps another server, in general, based on the path. It might be based on the request header, it might be based on anything. And generally, it's based on the path. So you would have, like, perhaps different domains with different web servers, perhaps same web server for different domains. I mean, anything is possible. Now, web server needs to do routing. That's a lot of responsibilities. So static content, dynamic content, load balancing, routing. And the point is, in general, people already have what they call a reverse proxy to do all of that. Who doesn't? Who directly expose their application to the outside world? No, nobody does it. But now, I mean, we are really, really using the web more than ever before. And since we have this super comfortable single point of entry, it's very easy to put more responsibilities into it. Authentication is one. You might have IP blacklisting, caching, everything. And now comes the problem. We want to integrate the system because the World Wide Web is so big that now it's not only about communicating with people, it's machine-to-machine communication. And again, from the historical point of view, file sharing with FTP. Who did that? Yeah, come on, don't be shy. Yeah, all people above 40 need to raise their hands. Huh? Yeah, so sorry, it gives a hint about your age. That's sorry for that. Yeah, and then you rename it when the job has been done, when it has been integrated. But of course, it worked when the volume of data was not that huge, when you didn't have real-time or near close to real-time requirements. But we actually need to do more. So first, we need probably synchronous communication at some points. But then if it's limited to your tech stack, it's a problem, because the world is just bigger than Java and C#. We might have Python, Ruby, whatever. And the thing is, the lowest common denominator around all those tech stacks is HTTP. So it makes a lot of sense to use HTTP to integrate those different systems together. And that's the point of an API gateway. So all of this just to explain you that the API gateway is just a specialized reverse proxy that is meant to add additional features to reverse proxy regarding the APIs. I mean, its name implies. But since I see a lot of questions regarding, hey, but why is an API gateway? I have a reverse proxy. It's enough. It's enough, but there are two things, in my opinion, that makes it unique. With reverse proxy, as I've shown, were designed in the time where it was very static. You add your configuration, you wanted to change the configuration, no worries, we switch the service off, we change the configuration, we switch the service back on. But for routing, I don't want to switch my service off. If I need to change a route, if I want to deploy a new service, I want it to be instant. Even better, I want to first deploy this new service, then perhaps send 10% of the traffic to this new route, then 20%, then. So I want everything to be dynamic. I want everything to be close to real time. So I want something that is easy to change. The configuration can be changed through, let's say, an API call. So first, I want dynamicity. The second thing that I want is something that is related to APIs, like basic API scenario I want to build based on usage. Most reverse proxies, you might create a plugin that does it, then I don't know if you are using Nginx, if you create such a plugin, I think it will be in C or C++, I don't remember. And then you need to compile it, you need to install it, and if you need to change the codes, again, bring the service down. So you want something that can be changed very, very quickly. There are a couple of API gateways on the market. So yes, I work for API 6, but there are others. So you don't need to take my word for it that API 6 is the best. Of course, it's the best, but you don't need to trust me. There are others. Some of them you can install on premise. Those are the ones that I know of. Some of them are cloud-specific. As Hadi mentioned, it's called vendor lock-in. You can like it. I remember I used Windows when I was younger, so now I'm very, very cautious about vendor lock-in, but of course, to each their own. And to talk about Apache API 6, it's not an old project. It actually was developed in 2018 and then donated to the Apache Foundation. So who doesn't know anything about the Apache Foundation? Okay, that's fine. And then it became a top-level project. The architecture is actually quite simple. We are building on the shoulders of giants. So we are using oh, it doesn't work. No, it works here, and it doesn't work here. Yes. That's not what I wanted to do. That's not what I wanted to do. And here it works like this. Okay, I have no clue how it should work, but let's say it's not a success. So we are using Nginx. On top of that, we have the OpenResty engine, which allows you to run Lua, and then you have like plugins out of the box. You can create your own plugins as well. I want to highlight two use cases, because when I start to play with a product, I I mean, there is the standard path and the stuff that you can use it for real. And I believe that here I will give you two, let's say, hints that you can use an API gateway, and it's not what you find in the docs usually. The first is how you can evolve your API bit by bit without breaking the service. And the second is how you chop a monolith, and I will get back to it afterwards. So, evolving your API. Imagine you have designed a REST API. It was super hard because you really wanted to implement the correct REST semantics, which nobody know about anyway, that everybody always, I know I am recorded, I cannot say bitch about, so I would say argues about. And no two REST practitioners agree on anything most of the case, but still you manage to do something. So probably you didn't have time to plan how you would evolve your API. So first lesson, plan how to evolve your API. But as I mentioned, in general, you don't have the time. And if you didn't plan, you shouldn't break the clients. But again, it's very hard not to break the clients. But if you break the clients, you should break them smart. So let's start. The initial situation, step 0, you really are a junior developer, you expose directly your application to the internet, it's really bad idea. So step 1, you already have an API gateway. The API gateway actually at the step 1 does nothing, just routes, just protects, because again, it can do whatever a reverse proxy does, but anyway. The second step is actually to introduce a version resource. So you add an additional route to your API gateway that points to the same place. So at least, when you change, you should change the documentation. The new clients, when they come, they will use the version route. So you don't accrue more people using the old route that you will need to break. At least you stop the hemorrhage. Let's use HTTP semantics. We should use redirect saying, hey, you shouldn't use this thing anymore. So you return a 301. Of course, it breaks the clients. Or not. There are two ways. Yeah, there are two ways. So either the client code is smart and follows the redirect, doesn't break them. Of course, in that case, they are not aware there is a new endpoint. Or it breaks them, and then in the logs, probably, there will be plenty of alerts saying, hey, we have issues. And then they can check, oh, 301, what's the new location? Let's change the code, let's change the configuration, anything, let's redeploy, and we are gone. There is no choice, because again, when you open a new API, probably you didn't plan. You want people to use your API. You want to be as smooth as possible. And if you make people subscribe, probably they won't use it. Who likes subscribing? Then you receive not super great emails every now and then. You need to click unsubscribe, and of course it doesn't work. And yeah, nobody loves that. So you open your API, you make it very easy, but then you don't know who your clients are. Of course, at some point, you will need to make user register because you want to know your clients. Because you don't want, again, to break them when you change your location. But who likes to register? Nobody. So you must make the people register, but in a smart way. And in general, what you can do is you can say, hey, up to X requests per minute, seconds, hour, day, whatever, you're free to go. But once you get serious about it, you need to register. So you have a limited cap and perhaps 2 limited caps, or how many limited caps, I don't care. But basically, you provide an incentive for people to register. And again, you can be you can use the HTTP semantics, and if they call your API too often, 429 with the message, hey, please register as this address, to enjoy unlimited calls or less limited calls. In general, at this step, you want to use the API gateway to do canary release. But before that, I will really implore you to be smarter than that. Before you do canary release, what you can do is you can duplicate the production workloads to test your API. So basically, the new version, the V2, will also receive the production workload. The response will be discarded. But at least you will check that your new code copes with the current workload. There is no, in Java, null pointer exceptions, in Python, nil, or whatever. So duplicate the production workload, checks that your new code still works. Then you can do canary release. Canary release, you will send a portion of the workload to the new version of the application. So, and there are multiple ways to do that. You can say, hey, people who are inside the organization will receive the new version. You can say, hey, 1% of the workloads will be driven to the new version. It can be a header for testing purpose. It can be for anything. I mean, that's what the API Gateway can help you with. So whatever you want, you can do it. Canary release for the win. Last step. At some point, you want to deprecate your V1 because you don't want to have two different code bases that you want to maintain, or more than two different code bases. There is an IETF draft for that. It's called deprecation. So you can deprecate your header. You can deprecate your endpoint with the deprecation header. It accepts date saying, hey, it's deprecated, or it accepts a Boolean saying, hey, it's deprecated, or a date saying, hey, it will be deprecated at this date. And then you have a header that points to the new location. And if you really want to be serious about it, you have the sunset header. Because first you will be saying, hey, I will deprecate it, meaning at this point in time you shouldn't use it anymore, but you can still do it. Then the sunset means, hey, I stop the service at this time. So you can do it in a very gradual way. Last step, enjoy. If you did everything, then the next changing of your API will be very easy. Because people will have subscribed, so you'll know them. You can send them emails. You can communicate with them. Much easier. Any question on this? No question. Next step, chopping the monolith. So that's the other use case that, in general, you don't find in the usual use cases of API Gateway. Imagine you have, I dislike this word because now it has a negative connotation, but I will use it in a neutral way. You have a monolith, so a single piece of software, and you want to release often. But of course, every time you release, you need to test the whole app. And that's a problem, especially the bigger your application is, the more tests you need to do, the less frequently you can release. Conclusion, you want to do microservices, right? Right? Yeah, that was a trap. Of course not. Who here in their right mind would want to do microservices? Don't be afraid. Yeah, German people. No, I mean, I don't want to do microservices. I don't want to do microservices because now I need to handle a lot of stuff in the code that was handled for me by the database, like transactions. How do you handle transactions with microservices? Oh, I have the Saga pattern. Yeah? How long does it take you to code it? Huh? Did you test it? Does it really work? Yeah, I have a database it's transactional. There have been like millions of tests. That's fine. So I don't want to do microservices just because to put it on my resume. But as I mentioned, I have quite a bit of experience, which is a nice version of I'm old. And we had these requirements before. We had these requirements before. We want to release more often. Because in the good old days, and a good with quotes, we had so-called release trains. Who still have release trains? Hey, don't be shy, it's fine. I mean, it works. You had release trains, so basically you could deploy, let's say, 4 times, 2 times per year, depending on the size of the org. And of course, then the schedule at the end of the coding period, just not to miss the train, was a bit, let's say, interesting. Because you don't want to miss the train, because if you miss the train, you need to take the next train, which will be in 3 months, 6 months, depending on the org. You don't want to miss the train. And of course, because we live in a world populated with humans, sometimes we miss the train. And of course, between trains, the only thing that could be deployed were bug fixes. How many of you did see new features covered by bug fixes? Yeah, that's life. Now you understand why I'm not a consultant anymore. So the biggest issue is you cannot release that often and test monolith well. But the real problem is not the deployment problem. You don't care about deployment. Deployment is your problem of IT. What the business wants is they want to have something new or updated, like running. And we translate it by we want to release more often. But I'm sorry, but it doesn't work like that. So the first thing to realize is that, yes, indeed, not all parts of an application change at the same pace. But the microservices people, they say, hey, all parts change quickly, so we need to put them in microservices. And I dare you to find me a really good use case. That's not true, unless, as Harry mentioned, you are Netflix or a big, big organization. So I don't know, but perhaps you have heard about rules engines. And guess what? This is exactly this. With a rule engine, you are saying, hey, this part of the application changes very frequently or very arbitrarily or whatever. I will like chop this little port, put it in the rule engine, and now, when there is a need to change, I give the keys to the castle to the business, and it's up to them to change it whenever they want. Of course, with great power comes great responsibility, meaning if they break something, then it's their problem. It's not the responsibility of IT. We want to test because we are responsible for what we deliver. Now, if I give you the keys, and you are responsible for it. This is how some organization handled it. Now, between us, I'm not saying you should use rules engine. I had a look once at how it was implemented. Basically, if you were not an IT specialist, it was impossible to change it. And if you were not a business expert, it was impossible to change it either. Only for very, very simple stuff. So I'm not saying you should do it. I'm saying, hey, that's one way to solve it. But how do you know which part changes that often? In general, you don't. You might assume that something might change differently, but so the thing is, probably you should start with a monolith, check which parts are changing very rapidly, and then isolate them, chop them, or at least chop one. And then it can be a rule engine, a microservice, a serverless, or whatever, I don't know. But then you can put it away. And actually, I don't know if you know this microservices pattern book and website by Chris Richardson. And this is exactly what it describes. But the problem is, since it has microservices in the name, then it chops all the parts. And my point is, just chop the parts that are necessary. And probably there will be one or two parts. Again, it depends on the context. And afterwards, enjoy. Because you can still have the client send the requests, but then you will add a new route that say, hey, if you call this path, then you direct it to the chopped part. And you don't need to change the monolith. It's just that the request will never reach it. I've worked in e-commerce. I don't like it, but I think it's a good example for many, many, many use cases. So imagine you are an e-commerce provider, and you have decided that actually, or you have realized that the fastest changing part in your application is the pricing engine. Pricing changes all the time. Well, pricing changes all the time, of course, but pricing rules change all the time. So you could design a pricing engine, and you can account for all those rules, but probably at some point, there will probably be the business coming to you and saying, hey, I have a new rule. So not great. No worries. We chop the pricing engine. We make it serverless. We make it a microservice. You make it whatever you want. Then you can deploy it independently. So my point of this talk, if you need to remember something, is in a world of APIs, API gateways are a must. Stop thinking about reverse proxies. You probably will have reverse proxies in front of gateways, or perhaps the gateway will do everything, but you should really, really up your game because they are designed around APIs. And well, Apache API 6 is fully open source. Not only it has an Apache v2 license, but it's managed by the Apache Foundation. So thanks for your attention. You can read my blog. You can follow me on Twitter. You can check more about Apache API 6. And now the nice gentleman told me that I have 10 minutes left. So if you have questions, we have 10 minutes of questions.
Yes. So yeah, let's start with any questions in the crowd. Do we have any from here? Because I do have one that was sent.
Perfect.
Okay, we can start off with that one. Can I use API 6 as K8's ingress? Does it integrate with Cert Manager?
So for the first question, yes, it can be used as an ingress at the moment. We are also working. There is a new specification regarding gateways inside of Kubernetes. So basically, yes. And for the second question, I don't know. Yeah, that's why I was a bad consultant. I say I don't know.
You don't know. There you go. All right, well, thank you. Any other questions on this?
You were super surprised, like.
That you don't know.
No, that I told people that I don't know, because I could have like said, no, I don't know. I'm not a fun guy, I told you. Thanks a lot, and enjoy the evening.
Yep.